I think the first thing I should say is that I speak about this topic as an outsider. When we were developing this session, when the International Development section were developing the ideas for this session, I hadn't, in fact, expected to be one of the speakers. But for various reasons, it's worked out that I am going to just, in a way, to summarize some of the issues that I see are important as a statistician from a particular social statistics background, really, in terms of understanding and assessing the effectiveness of biofortification. And one of the statistical challenges is, of course, the one that Ruth has just been talking about. So I'm not going to say any more about the issue of measurement error, not because I don't think it's important, but because I think she's covered it very well already. But I am going to try and put some of these challenges in a slightly different perspective. Particularly, I think, the way in which people have alluded to the need to understand these things not only from the perspective of a trial, but also from the perspective of if these things were rolled out in the longer term. But I'll start with just saying something very briefly about trials. And we've heard a little bit about these different trials, particularly for biofortification, there are these different routes, conventional plant breeding, such as the trials to assess the effectiveness of orange flesh sweet potato in Africa, the effects of biofortification through fertilizer, as in Pakistan, and as Edward mentioned, the selenium trial in Finland. And I think what's actually quite interesting about this, the fact that there is this program in Finland, is that it illustrates that this is not entirely a developing country issue, and that's true about many things that we find, particularly with the sorts of things that we think about in the international development section, that we find that not all of these problems are specific to developing countries, that they actually cross the divide between richer and poorer countries. And then there is the final way of creating biofortified crops, which is through genetic engineering or modification or genetic gene editing. And this is very controversial. Many of you will be aware of this. And so the development of golden rice to address vitamin A deficiency has been subject to an awful lot of controversy and a lot of disruption, because people feel that it's some sense the thin end of a wedge towards more wholesale genetic modification of food crops. But perhaps the tide is changing a little bit, and there are now field trials of golden rice in Bangladesh. What I think the first thing that strikes me about this, again, as I say, coming as an outsider, is that my reading of the literature, and I'm very happy to be corrected, but my reading of the literature is that they are not very complicated experimental designs. And I suppose I have in the back of my mind Fisher's dictum about making your experiments complicated. We have these different methods of approaching this issue of food fortification or biofortification. But as far as I can see, there are not a lot of trials which are actually comparing across the different kinds of approaches to fortification. Now, clearly, you would have to do that in a very intelligent way. You couldn't just make a comparison of golden rice with orange fresh potato. It wouldn't make sense, because obviously rice is a staple in some parts of the world and sweet potato a staple in other parts of the world. But nevertheless, there seem to me to be opportunities for designing trials that enable us to understand better what the relative effectiveness is of these different methods of fortification both of biofortification and to compare these with food fortification, the industrial food fortification that Greg was talking about, and food supplements. To not do that, it seems to me, is that we're missing an opportunity to get a better understanding of what might be the most effective way of dealing with these problems. And as I say, you can't just lump them all together, of course, and they are trying to reach different parts of populations, but it seems to me that there is a case for being perhaps a bit more imaginative in the way that trials are designed than I have seen in the literature. But as I say, I might be missing some things. So I think that's the first challenge, which is a study design challenge. The second thing I want to talk about and to spend a little bit longer on is to put this in the context of the Sustainable Development Goals, which many of you, I'm sure all of you will have heard of. And it's an issue that we take very seriously within our section. And goal 2 of the SDG is to end hunger, achieve food security, and improve nutrition, and promote sustainable agriculture. So that's goal 2 out of the 17, I think there are. Within that, we have target 2.2. By 2030, end all forms of malnutrition, including achieving by 2025 the internationally agreed targets on stunting and wasting in children under 5, and addressing the nutritional needs of adolescent girls, pregnant and lactating women, and older persons. So these are strong targets. What is particularly important for statisticians is that connected to these targets are a very large number of indicators. In fact, over the whole set of the Sustainable Development Goals, there are 244 indicators. And every country in the world is expected to provide data on these indicators. It's an enormous task. One of the indicators, and the most relevant one for what I'm trying to talk about here, is the prevalence of stunting, where height is below 2 standard deviations from the median for a fixed age from the World Growth, WHO growth curve standards among children under 5. And not only are countries expected to provide this information, but they're also expected to disaggregate it by a whole bunch of explanatory variables, sex, age, and geography, and so on. So it's an enormous task. But the reason I bring this in is that if we are to observe an effect of biofortification or food fortification more generally, one would expect it in some way or other to show up in these indicators for the Sustainable Development Goals. So if these are being effective when they're rolled out, in other words, let us assume that the trials have shown that these programs work on the groups that they've been tested on, to the extent that it is now expected that they'll be rolled out. And I think Edward was talking about the sort of long chain from the initial idea to the to its finally being rolled out, or sometimes it's called mainstreamed. If we are to observe that, then we would expect to see those effects showing up in these kinds of indicators. So it seems to me that we should be able to use the indicators that are part of the Sustainable Development Goals as a way of monitoring the effectiveness of these programs in the longer term. So I think the second challenge is if biofortification is, for example, to reduce zinc deficiency in South Asia, where we've seen that that's an issue in Pakistan, for example. If those programs were scaled up, would we be able to monitor the effects on child growth using the kinds of statistics that are provided by national statistical systems? Because I think that's, that's a way in which we can perhaps judge the effectiveness of these programs at a population level rather than just at at the level of the trial. Oh, come back. So in order to do that, we do need some data, and this is, I think, where it becomes very difficult. These are the SDG data provided by UNICEF on the prevalence of stunting, and I've chosen Pakistan because we've talked about Pakistan in this session, and particularly about the prevalence of zinc deficiency in Pakistan. Now, clearly there's an underlying theory here which says that if you can reduce the level of zinc deficiency, this will have an effect on stunting. And clearly it's not the only thing that determines whether a child is stunted or not. But one would hope that you might be able to pick up the effects. But when we look at the kinds of data that are available at the population level for Pakistan, we see these are the UNICEF data. So these are the data that UNICEF believes comes closest to this target in the Sustainable Development Goals, for that target 2.21. And you can see that there is a time series with a lot of gaps. What you observe is that there appears to have been quite a substantial decline in stunting between 1986 and 1992, and that it hasn't changed at all since 1992. But these are data sources, these are time series constructed from different data sources. Only in 2012, which is the most recent study, at least as far as the data on the UNICEF site go, only in 2012 are we given any sense of uncertainty in these estimates, so that the figures in brackets there, the prevalence is 45%, but the confidence interval is 42 to 48%. And only in the most recent survey is there any kind of breakdown of this prevalence of stunting by these different groups, which is what the expectation is for the social development goals. So you can see that there is some variation, as you would expect. Those children born to and living in families in the lowest quintile of wealth, the prevalence of stunting is greater there, 61% compared with 45%, which is the average. And then there are some other breakdowns, and the last one is KPK is the province in Pakistan where I think one of the trials is taking place. And I know that the first K stands for Khyber, but I'm not going to try to tell you what the P and the K stand for, but it's a province in northwest Pakistan. And in fact, interestingly, there the prevalence as reported in 2012 is actually slightly lower than the national average. So it sort of slightly raises the question why you might choose that area, but I'm sure there were very good reasons for that. So clearly it's going to be quite difficult on the basis of these data to answer some of the questions about the efficacy of biofortification, and indeed to answer questions about the general time trends in stunting for Pakistan. But you might think that these are not sufficient data, but if you wanted to do the same thing for the UK, you would not be able to do anything, because there are no UK data on the ONS site for the Sustainable Development Goals on stunting. So, and this is another illustration of the fact that the sorts of things we're talking about partly are particular to developing countries, but the sorts of statistical issues also apply to the UK. And at the moment, the UK, although I'm sure it's not a a serious problem, it would be wrong to assume that the prevalence is 0 in the UK, particularly if you were to disaggregate. So in some ways, the data situation in poorer countries is better. So, as I see it, the third challenge is to what extent can we attribute changes in the prevalence of let us say stunting, but it could be other conditions as well, to scaled up biofortification. Because we need to be able to assess at a population level whether these changes are being observed. And I'll end with an example, a different example. It seems to me a way, a possible way in which we might address some of these questions if we had these kinds of time series data. Now this is, in a way, an analogous situation, although it's a very different example. On the left-hand side, you have a profit rate. The y-axis, the x-axis is just year, and the right-hand side there is the percentage of uptake, the percentage of crops which are grown in Haryana, which is one of the cotton-growing states in India. This is the percentage of crops, cotton, which is grown in this state in India, which are genetically modified. This is what they call BT cotton. And this is cotton which is now very widely used in India, which has been genetically modified to resist the attacks from bollworms. And so this is a technology which you could imagine is a little bit like biofortification. It's a technology which has become more and more popular over time. So there was no BT cotton up until 2005, and then the red dots show you how the uptake has changed from 2005 up to 2015, and the black dots show you how the profit rates changed over the whole time series. So what we have is an interrupted time series, but where the interruption is not 0 or 1. The interruption is a gradual penetration of this technology over, over time, which we could then model to observe whether there has been an effect or not. So I think those kinds of methods offer the prospect of an analysis of biofortification as well. So I'll summarize just by saying quickly, we need comparative trials and meta-analyses. We need disaggregated time series and repeated cross-sections. We also need longitudinal data to be able to observe within child changes as well as differences over time. And we can model time series which are interrupted by an intervention if we've got enough data. But the data is, I think, a very serious worry at the moment. So I'll stop there.